I think so, right? I think we need to do more of this because this thing costs, that other thing costs like $16 and we did that like twice. This thing I think costs like 80 bucks. Yeah, so don't play with my demonstration equipment. All right, so here it is. And then, all right, now, it's always a good idea to keep a few old textbooks around. Okay, they come in very handy in the education process. All right. Uno. Uno, dos, tres. Cuatro, cinco, mucho, mucho. I can't even get into it. All right. Incendios! Muchas gracias. Muchas gracias. Whoa!
Hey! What did he say? What did he say it's going on?
All right. All right, so the moral of the story is that if you are running across the top of a train, okay, and you're coming to a low bridge, like in a James Bond movie, right? Okay, two things you can do. You can lie down on top of the train because the bridges are quite low. There's only like 3 feet of space or something above the train, right? You know, you're quite low. You can either lie down or jump really high. You know, if you got like a good 10-foot vert, right? You know, jump up over those railings that they've now put on all the bridges, right? But if it's a very low bridge without railings, right? You might be able to do it with, you know, I don't know, what's a good vert? I don't know, you know. Okay, but there it is, right? Obviously, if you're trying this with a ping pong ball and a convertible, right? Air friction is going to affect that, right? But really, basically, this works because of the notion that the horizontal and vertical velocity are independent. In fact, if you were an ant riding along on this cart, somewhat dangerously, I might add, right? right on this edge, and you saw that, what would you see? What would it look like to you? What would it look like to us? To us, it looks like it follows a parabola, yes? It goes up, it goes down, right? Okay. To the ant, it looks like what? It just goes straight up and straight down to the ant riding along with it, yes? This is a type of relativity, and when we talk about relativity next year, I'll talk about that then, okay? But basically, what it just means is that if you're moving at a constant speed with respect to some other frame of reference, I can throw this thing up in the air, it'll come down. Now this doesn't work if you're going around a corner, it doesn't work if the car's slowing down or speeding up. In either case, it's not going to land straight back in my hand if I throw it straight up. But if it's a constant speed, yeah, it's going to land right back in there. One last burst of applause for this guy. All right.